One way to visualize a set of data is with the use of pie charts. This simply divides the data into groups that can show relative size of each group. Pie charts have a place in descriptive statistics, but have limitations. They cannot show changes over time with the same precision as other forms of descriptive statistics. Stem and leaf plots are another crude beginning of creating a picture that shows us the shape of the data. This form of presenting data lists the data in groups of decimals. The tens number are listed first, the stem, and then the remaining numbers, the leaf. They're placed next to the stem, and so on. The result is a picture of the frequency distribution of the data. At a glance, we can see that the data in this example is highly concentrated in the 20s level. More advanced are histograms. There are two types, one that measures frequency of data, often called frequency distributions, and one that measures relative frequency, which actually is a measure of probability. The horizontal axis is labeled with the data represented, for instance, distance from your home to school. The vertical axis is labeled either frequency, for frequency distributions, or relative frequency. That can also be called percent frequency or probability. To create a histogram, you first need to tabulate the data into the groups you believe to be relevant. These data can then be used to make a frequency distribution. For a variable that can be divided and divided again and again, what we call a continuous variable, it is often helpful to use frequency histograms. The data are put into groups of particular width and then become a bar chart. Here's a frequency histogram for hours spent playing video games for a sample of 25 students. The choice of the width of the histogram for a continuous variable is of some importance. Be careful that there are not too many bars or groups, or too few. Too few will compress the data and disguise variations that may be of interest. Too many will stretch the data and reduce the value of creating the frequency histogram in the first place. To create a relative frequency histogram, we calculate relative frequencies by dividing the number of occurrences into the data, the frequency for each category. The equation for this is relative frequency equals frequency divided by n, the total number of observations in the sample. This is done here for the frequency histogram for hours of time playing video games from before. An important feature of a frequency histogram is that you can actually calculate probabilities of finding a particular outcome in a random draw. Because the proportion of students who, for example, spend between 15 and 20 hours playing video games on the weekends is 28% of the group sampled, we can say that the probability of randomly drawing a student who plays between 15 and 20 hours each week is 0.28. Another method of displaying data is unique to data that is sequential. Tracking a variable over time is used in many situations. These data are called time series data and can as easily be graphed with the value of the variable, for example, college tuition, on the vertical axis, and time on the horizontal axis. This intuitive way of presenting a picture gives a quick view of how the tuition has changed over time. This is a great example of the goal of descriptive statistics, to show in a picture what the data says. Again, the goal of descriptive statistics is to show how the data are related to each other, meaning the location of the data and the shape of the data.